Hi students, my name is Sakesh Shetty from AJ Engineering College. The main topic is Module 1, Surface and Groundwater Resources. In that, hydrological cycle is very one of the important topic. Today we'll discuss about what do you mean by hydrological cycle. So that we'll discuss today's class. So that is one of the important topic, that one. You know that various forms of precipitation is there. Let's start from the ocean. In the ocean, due to the solar radiation, lot of evaporation takes place. There is some precipitation in the form of rain and snow. This we'll discuss later. When the rainfall, there might be some evaporation directly from the rain. Rest falls on the surface, either goes into the ground as infiltration or runs off in the form as a runoff, and it reaches to ocean, and some water is deposited in lakes. And next it will say hydrology cycle is continuous. The lot of components is the hydrology cycle. For example, we can say in the field working in the field of irrigation, we like to know how much water is reaches to the ocean. Everything we should know, inflow and outflow. But if you are in this model, we are concerned about water resources, how much water is going to the rivers, so that we can control floods, or we can avoid lack of water for irrigation, availability of water for irrigation. So let's look at some components. Precipitation. We will start with the discussion of the precipitation, various forms. In India, typically worry about rains, snow, hails. All of us know the rain is the important parameter. Snow, of course, we have seen in India, not much lot. In western countries, colder climates, snow is the main parameter, and hail and glaze and is also forms of precipitation. In chemistry classes, I have seen precipitation of solids, similar forms. Think of rains as precipitation liquid, and in the atmosphere there is a lot of water vapor, and condensation causes and that water vapor, and it drops in the form of rains depending upon the temperature at the time. Various forms of subclassification also there for rain, light, medium or heavy, depends on how much water is falling at 1 hour, let's say 1 hour. When we studied mechanisms of rains, it can be caused by various different forms, mechanisms, kinds. Important thing is there is a mass of water vapor which should be cooled down. Water condenses. So for cooling, we have lot of different mechanisms. Frontal precipitation mechanisms, where the front surface of contact between two different air masses in different temperatures. When warm front, warm air, for example, ground surface, warm air going for the sides and its counters colds. This is a frontal lifting. Or when it's warm air tends to rise and it goes off due to adiabatic reaction, this water vapor, it condenses cold water vapor, and it is cooled down. This is called frontal precipitation or frontal lifting. In the next form is our convective lifting. We can say we have surface of the earth which may be warmer, and therefore the air in the contact with surface, because of high temperature or low temperature, it tends to rise. When this air rises, when its precipitation takes place. And third mechanism is orographic lifting or orographic precipitation. In this form, we have mountain and air coming in when it's rise, because when the rise in the ground elevation, when it rises up and it's started to decreases and it falls down, that is called orographic lifting. Finally cyclonic precipitation, especially in coastal areas. Cyclones, which are winds very high altitude, and that's carry a lot of moisture, and it's come off land, and it's called cyclonic precipitation. This precipitation is important to know in the different types of certain time. Therefore, next topic is measurement of precipitation. Basically, two types of precipitation is rain gauges. We can measure the one is non-recording type rain gauges, and another one is recording type rain gauges. Non-recording type rain gauges means continuation variation of rain. We will go manually or once in a day, see the instruments how much rain has collected. Recording type rain gauges, we have continuous recording of rain gauges as it falls, as it may be recorded. In the non-recording rain gauge, non-recording rain gauge. This is the diagram of, and the top of we have funnel, should carry the rainfall fall on it. This can carry the water, and its cylinder is there, bottle is there, carry the water for that. You can see the marking in that, how much has rain is fallen in that bottle. Typically in India, 8 or 8:30 a.m. person who goes and look at that and rain gauge reading finds how much water occurred in the previous day. So it fixed time is every day somebody goes and check the amount of rainfall. And the recording rain gauges, continuous record is there. Recording. There are three different types of rain gauges is there commonly used. Most common is known as tipping bucket rain gauges. The more common is that. In the tipping bucket rain gauge, which is shown here, again we are having funnels, collect the funnel. There is arrangements here which is known as the tipping bucket, which has two compartments as shown in here. One of the compartment is below the funnels and it collects all the water, and when fixed amount what has entered into the bucket, it tips over and it rotates, and other components comes along with that funnel. This will goes here, and the other components comes below the funnel, and then it starts collect. When it tips, there is a magnet here, and it sends a signal, some of the recording devices, and we know how much time it will to fill the one side of the bucket, and we know how much rainfall has been collected at the time. That takes a record these tips, which tells us what is the intensity of rainfall. The data obtained in the non-recording rain gauges can be displayed in the form of hydrographs or masker. Now hydrograph plot of time versus intensity. Intensity of rainfall is typically expressed in terms of millimeter or hour, sometimes in centimeter per hour. And if we have non-recording rain gauges, then what data will have can be expressed as um, daily values of intensity. For example, in the first day we collect 2 millimeters of rains, we can express the intensity and it would be better in that case change in millimeter per day. So we have 2 millimeter in the hour in the first day, and second day, and suppose it's second day in 3, we can write it. Since we don't know in that day different rainfall occurs, because we are collecting the data every 24 hours, we cannot show the variation within a day, one day. It will give the graphs, but we cannot say this is the rainfall because we are collecting daily basis. So we can show the using a hyetograph how the rainfall intensity varies with time. Second type of curve we can show the rainfall is variation is mass curve, and the mass curve again time shows the accumulated depth of rainfall. That is also one of the intensity shows how intense is the rainfall, how much centimeter hour or millimeter hour, and mass curve shows how much depth is accumulated from the starting. So again it would be say that it's time and day, or day also we can say accumulated rainfall is maybe in millimeter or centimeter. In the first day, suppose for example first day we can say that it's 2 millimeter per hour, it would be 2. Second day, suppose we have another 3, and how the graph plot we using the mass curve we can plot it, that how the rainfall will vary in that particular day. It's continuously increasing because accumulated rainfall or depth of rainfall. For recording rain gauges, typically you get a curve directly gives us a accumulated rain depth. In the recording gauge, the tipping bucket we have seen. Another one is not so common because more expensive, um, and which is known as weighing bucket type bucket rain gauge. In the weighing bucket, as the rain falls on the bucket, on the rain gauge, it gets collected and signal is sent to immediately to record how much grade is increasing with time. So what we get directly mass curve of rain, which we can directly plot. That is the main advantage of the mass curve. So directly we will get the accumulated rainfall reading, and it will send to the main authority what is the main rainfall. It is the unit in millimeter or centimeter per hour times in hour per day. So this shows the accumulation of rain in the rain gauge over time, and we look at that. Sometimes if there's no rainfall, it shows slope of the curve shows the intensity of rainfall. Wherever the slope is largest, the intensity of rainfall is very high. Where is less, there is no rainfall, the low intensity. If it goes straightwards, there is no rainfall. Mass curve slow, it will goes the rainfall, changes variation, and we can collect the data to rain from the rain gauge. Therefore we important to know the rainfall, what should be our network curve. For example, if you not find out the rainfall over a certain area, how much rain gauges should report, where should locate it. For example, one option would be gauges any place of the watershed, or we may add more rain gauges in that particular location. There are some guidelines is there how much area, how much gauges should be used. For example, in India, the guidelines are for 1000 kilometer square area, if we have plain area, 2 rain gauges are sufficient. 2 rain gauges for plain area. If you have moderate elevation, for example 1000 meters elevation, then we may need 3 to 4 rain gauges in 1000 kilometers square area, because variation of uh, special variation of rains, it's like to be more in that plates. In hilly areas, typically we need to 8 rain gauges in that particular area. So these guidelines should be followed in the designing rain gauge network. And another guidelines is 10% of the rain gauges should be of recording type rain gauges. So if you have, let's say, 15 gauges in that area, 1 or 2 should be recording rain gauges. Based on the record of that 1 or 2, we can estimate temporal variation of rainfall on the other station. So that reasons this much percentage should be required for recording rain gauge. Once we collect the rainfall data, we should analyze the data. Next thing we discuss about data analysis. In the data analysis part, let's start with suppose we have network of the rain gauges in watershed. We have collected data over, let's say, a period of year. All the database, some data is missing, I guess. Some rain gauges one place where we have data every day. One day person who was supposed to collect could not go there, therefore we are having missing data. So how to find out estimate the missing data? That is a major challenging part. First thing we should, if we collected data for number of days but we have missed one day, how to estimate one day data missing value? So that is very much important. That is important thing is of course different method is to see that we have missed one station, but we have values of available at other station. We can take some kind of mean all the values of other values and say that is the value of the related value of that point. Let's say other stations, so that we can say that missing value at x could be mean of all the other values of precipitation and that day, and estimate the missing value of that one. But there is a problem is method when wide variation of rain in that area. For example, one gauge may be recording higher rainfall and compared to other gauge in general. That's why we have to look at normal precipitation at the various gauges. When this normal precipitation, typically say normally we can say that they can have authority. If you are looking at May, then we can consider what is the rainfall those stations on May 18th. If you consider May 18th over the past 30 years, average of those values would be cost a normal precipitation that rain gauge for that day. If you are missing precipitation at that station on May 18, we can estimate it based on the precipitation on that day for all the gauges and their normal values. Formula we using this case takes care of variation in the normal rainfall other station also. It's similar formula, Now instead of estimating rainfall, we have to estimate ratio of rainfall with normal rainfall. That way we can estimate what is the missing value. Next important thing is look for is whether data is consistent or there is any inconsistent. For this purpose we use what is known as double mask curve. We are using the double mask curve. Assumption is data is consistent, follows same trend for number of years compared to other stations. So we plot the double mask curve, which was accumulated. Mask curve means accumulated rainfall, precipitation, accumulated precipitation at x-axis, let's say 5 or 10 nearby stations. Versus double precipitation at accumulated rainfall versus accumulated precipitation at where we want to find out the data of consistency or not. And if the data is consistent, typically it would be follow straight line, minor variations. But if there is some changes in the characteristic catchment or the gauge has been shifted, some inconsistency, then it will be see data does not follow single straight line, or it may deviate from that position. If you plot the most recent data, if there is a break somewhere, if you consider somewhere it breaks, then we can find that some 1980, for example 1980, there was a break in the curve. So it will tell us that the data is not consistent, some problem. Either 1980 gauge was different location, or gauge may be shifted, or some changes in the pattern, precipitation pattern, natural factors. For example, there may be lot of vegetations which was removed. There could be number of factors considering causing for this behavior. Uneven consistency data can obtain double mask curve or accumulated precipitation nearby precipitation. Once we estimate the data, we can check the consistency. We can go for, we have certain area, we want to find out rainfall in over that area, values of that precipitation, only this rain gauges, that point we are calling it as the point rain gauge points, point values. Out of this point value, now we want to estimate what would be the average rainfall over that area. So we can call it as the problem is given point rainfall values at the rain gauges, how to estimate average rainfall entire area. And there are number of techniques again do that. We can discuss what is the different method to find out the simplest one is arithmetic mean method. Arithmetic mean, we can say that simplest method arithmetic mean is just we take mean of precipitation values at all the stations. If you have, let's say, 8 stations, arithmetic means mean to separation of that area would be sigma of I, sigma of whole. It means whole average precipitation divided by number of points. The drawback of this method is very simple. We don't give any work to that location of that gauges in that area. So if we have an area where let's say 4 gauges are there, 1 gauges are there, so take the means without considering the don't represent as much as area. This one how much area does it represent, it's not accounted for arithmetic mean method. So modification uh, uh, actually proposed for Thiessen, this is known as Thiessen polygon method is there. Thiessen polygon method, in which relative position various gauges also we consider in this. We have rain gauges in that area, and also we can consider different techniques is there here: normal ratio method, and comparison method, and arithmetic method, and normal ratio method, and comparison method. If the rainfall record of rain gauge station is missing for a relatively long period, such as month on area, it can be estimated comparing the mean annual rainfall of the station X with that an adjoining station A. Here that is also simple method, normalization. Here compute the average precipitation. We give the weight individual rain gauges. So we can consider Px by Pa is equal to Nx by Na. That is also one of the method to find out the rainfall, missing rainfall data. So where Px and Pa are the precipitation of the stations. So this tells us certain weight Px by Pa and Nx by Na are the mean annual rainfall of the stations X and A. This is a comparison method. This takes care of some of the drawbacks of the arithmetic mean method compared to for the account the position of the gauges, but it doesn't account for variation of the topography. So for example, there may be mountainous area in that area and plain area. So there is a short changes in elevation. So Thiessen polygon method not or comparison method is not accountable. Therefore, we have another method, that is we can get isohydral method, isohydral map method, which accounts for variation topography. Also we can get individual precipitation values and drawing isoheights. Isoheights are nothing but lines of equal precipitation. If we have precipitation at all these stations, look at that values, losing that values, we could draw isohydral lines. For example, one rain gauge is 8 millimeters, and that joined all the 8 millimeter precipitation points, and values at same precipitation, and 10 and 12 millimeters. Just draw that, and let's join that lines and draw the isoheights. Then assume that the area between the two isoheights as rainfall choose the main value in between that values, and in between that two values in that area has rainfall of 9 mm. We can consider if 8 and 10 mm values is joined, in between that it comes, that is 9 mm. Or 10 to 12, in between that values comes, you just join that one, and we'll get the, after we can get the average rainfall over that area in terms of P bar. And suppose P1 and P2 are the P1 plus P2, P1 P2 are the surrounding isohydral areas. A is the area between them, and sum of the average precipitation into area for all the isoheights. Now once we get the areal average, we can know what is the depth of area in that certain area. Then we can prepare what are known depth, area, duration curve. These curves, normal ratio, or normal ratio method. This is area maybe in kilometer square. If you know that area, it may be in this kilometer square, and we can dot the lines, area with respect to average depth, which may be in millimeter or centimeter. It will be the show the duration of that rainfall, which may be 6 hours or 12 hours or 12 hours, and this is the D narration. If you look at typical storm, center of the storm is the largest, therefore depth will be the very high. As we increase the area, that means moving of the other from that station. So that is also one of the method. So that is the formula is Px is equal to Nx by M and Pa by Na, Pb by Nb, and Pm by Nm. So that is, we can show that how much water depth is expected in that over that area if the rainfall occurs in certain time, 6 hours or 12 hours or any given time. So there is sometimes empirical equation also given for the calculating that variation of rainfall average depth with area as minus k power in the exponential. 30 is the point rainfall value which obtained from the rain gauges. Typically we say that rain gauges values depends rainfall over a particular location. Just kind of equation tells us at any given duration the average depth decreases the area. This value k and n depends upon the catchment area. Some typical values are given in the various textbooks about that different areas. The other aspects important is to some of a kind of frequency analysis or risk analysis to see the what are chances rainfall occurring in the next 10 years or next 100 years also, predicting the rainfall. So frequency analysis also very important from this point of view. So frequency analysis is nothing but deciding how frequent rainfall would be, and typically what we do is present and present intensity, duration, frequency analysis. Present in which how frequent rainfall in the certain duration. So the curve would we can draw. It falls down. That curve looks like it falls down. That intensity of rainfall, it's falling down curves. It's in millimeter per hour unit duration. Duration and the frequency or return period, we can say that one. Return period or frequency of rainfall. It always falls down, which may be rainfall of once in 100 years or once in 20 years. The frequency, of course, it would be reverse of time period. So we can write T is equal to 1 by probability. T is equal to 1 over probability of occurrence of rainfall. That is, it would be the discuss in future frequency curve. They help us knowing or designing and projects of or some structures against given probability of floods. If you want to design something very safe, we should go and for 100 years precipitation, 100 years so for this 100 years precipitation we can find out what will be the depth of precipitation, and those curves we can prepare in terms of duration, depth of rainfalls, and the time period. So that curve intensity, duration and frequency indicates different duration for rainfall. What will be the depth for a given time period? One should aware of that facts. Time period of 100 years that doesn't mean it's this much rainfall occurs for every 100 years. In general, 100 long period for analysis we are taking for this event is considering. It's not a mean, it's only once in 100 years it will happen, this much rainfall. Related to that, there is a concept of global maximum precipitation occurs for in a area. That probable maximum precipitation used in extreme cases, we to design something very critical, for example large dams or catastrophic. That case we can find out what is the PMP, probable maximum precipitation, which typically written as some factor in the standard deviation. Generally, value of k is we are considering here 15. P bar plus k into sigma. The mean rainfall is 15% of standard deviation. The normal taken at as in the possible mathematical calculation in that area, and this is used in critical designs to estimate the maximum floods which can be occurred in the given catchment. So in this lecture we have seen various aspects of precipitation and hydrology cycle, but we must realize that I was a water resource engineer. It's not a precipitation, it's really the run of how much water going to the rivers, which is more important to the class. Although an agriculture engineer, we need to study the underground study also, but most of the water resources engineering projects deals with the construction of dams, canals from the rivers, and therefore volume of the water going to river is more important, and also this depends upon precipitation and more concerned about runoff. Today's lecture we looked about precipitation. Out of this precipitation, part of it goes to underground, which is called infiltration. Part of it you will evaporate from the surface. Part of it will lost transpiration from the plants. Combine them and we will call it as evapotranspiration. So evapotranspiration and infiltration, and the other two, obstruction from the precipitation, and most of the rains goes to the streams and surface runoff. As surface runoff, part of it goes to the eccentric ground, again goes to the streams and ocean, and as underground, or what we can call it as base flow. After today's lecture, in which we studied precipitation, and thank you very much. And as we also discussed about infiltration, precipitation and storage tank, how much water taken out of the precipitation, and to finding it helps to find out how much water is going into the rivers and lakes. That everything we studied in this video lectures, and next video lectures we will discuss other parameter also related to that one, how much that means soil moisture, and how is the soil moisture is related to the infiltration or runoff, how it is converting it as runoff. Everything we will discuss about in that next lectures. This is related because when you are going to the water resource management, you should know that all the basics concepts. That reason I am explaining everything, the basic concept, because if you know the basic concept, we can write it theory in your own way. So that reason I am going to every the basic steps one by one, and in that, using that basic concepts, you can write in your exam related to all the concepts in water resource management. So in next we'll go for I think today's class we studied precipitation, how it's fell down, and how we can collect using recording rain gauges and non-recording type rain gauges. What is evaporation, what is evapotranspiration, what is transpiration, everything we study is today's class. And next class we'll discuss about the related to that also. Thank you very much for your patience.